Hello champions, this is Miss Tilly. I have set out some of the minerals we have in our kits to take a look at today in this video. I'm really bummed that we weren't able to do a lab on this in class and get you up close and personal with the minerals. But we're going to talk a little bit about minerals and a few of their properties during this video. I don't know if you remember from the notes and from the activities you've already done, but to be considered a mineral, an item has to have all of these properties. It has to be naturally occurring, meaning it's not only man-made. We can find it in nature. It's inorganic, meaning that it is not made up of living things or once living things. Something like coal is not a mineral because it comes from once living things. Has to be a solid with a crystal structure to it. Now, sometimes that crystal structure is microscopic. Sometimes we have to use microscopes to see it, but it has to have some sort of pattern of arrangement of its atoms. It has a definite chemical composition. We know what elements and compounds make it up. It's always that type of element or that compound that is at least in that mineral. It has to have all of those characteristics, every single one of them, to be considered a mineral. These are some examples of minerals: quartz, calcite, gold. Gold, which is also a element, can also be a mineral if it has these characteristics. Talc is an example, gypsum, and halite. Now, we can use some different properties to help us identify the minerals, and some of those properties include hardness, which we'll take a look at today, luster, which is how it reflects light, the crystal structure of it, like what is its crystal structure? Is it cubic? How are they arranged? That sort of thing. Density, remember density is mass per volume. We can start off by looking at its color, but the color does not always tell us what it is. For example, this right here, that's quartz. That's rose quartz, which is pink quartz. Quartz does not always come in pink. It can be different colors. A lot of times it's clear or white. It can be what's called smoky quartz, which is gray to brownish to black. There's all different colors of quartz. So color is not always an indicator of what it is, but it's a good start. The streak is the color of its powder that's left behind on what's called a streak plate. These right here are examples of streak plates, and you can see some of the streaks that have been left behind by some of the minerals. We'll do a little bit of streak test today on a few minerals. That right there, this little mineral there, is sulfur. Okay, we'll get back to that here in a sec. So streak, breakage, does it have cleavage or fracture? Remember, cleavage splits along nice, even pieces, nice, even lines. This right here, calcite, you can kind of see that layering to it. Not always are they layered, but that one is an example of a mineral that would have cleavage. Quartz is an example of a mineral that has mostly fracture. It would break apart into jagged pieces. So cleavage, even split pieces, fractured, jagged, split pieces. And then sometimes the minerals have unique properties, like they have a certain odor to them. Here we're back to our mineral sulfur. If you've ever smelled kind of a rotten egg smell, that's what sulfur smells like. It's a very unique mineral. It has a very unique smell to it. Some minerals are magnetic. They have elements like iron in them that make them magnetic. Some of them glow under a black light. They fluoresce. And I don't have batteries for my black light right now. I might try to set that up later and show you that. But minerals like fluorite and calcite actually fluoresce underneath a black light. They form a different color to them. Some can dissolve in acid. Things like calcite sometimes will fizz in an acid. Some refract light. Calcite, because of the way that its atoms are arranged, can refract light. And some can even conduct electricity. So some have unique properties that help us identify them. So that gives us some examples of things we can use to help us figure out what these minerals are, because you might look at a mineral or you might look at a rock and be like, I don't know what that is. So let me show you what we have in our kit here. The first mineral that we have has a hardness of 1. This is talc. And with talc, this is an example of our Mohs hardness scale right here. It gives you examples of some of the minerals that we have in our kit and what they can be scratched with. So talc is, if you look at it, it can be scratched. It's underneath a fingernail here. Fingernails are about a 2.5. Talc is a 1. So I can scratch this piece of talc with my fingernail, and some of the powder, some of that powder should come off onto my fingernail. It's a really soft mineral. Number 2 right there is what's called gypsum, and that can also be scratched with a fingernail. You can find gypsum in Indiana, and gypsum is a pretty important mineral. We use it in drywall or what's called gypsum board, which is probably in most of your houses. That is a 2 on the Mohs hardness scale. Coming in at 3 on the Mohs hardness scale is calcite. And calcite is also a pretty soft mineral. We can't scratch it with our fingernail, but a copper penny should be able to scratch it. So let's see. It won't scratch a penny. Let's see if we can scratch it with the penny. Might have to push a little harder. Kinda. So it is softer than that copper penny. Number 4, coming in at number 4 on the scale, is fluorite. And fluorite, you may have heard of it before. It is used in like toothpaste and things. It helps strengthen the enamel of your teeth and helps keep you from getting cavities. That is a number 4 on the scale. And let's see if we can scratch this penny with the fluorite, because the penny is actually softer than, yeah, I don't know. Can you see that? See where I scratched the penny? The penny is actually softer than fluorite. So fluorite is a 4, a penny is a 3.5. So fluorite scratched the penny. So say I have an unknown sample, I don't know what it is. It doesn't mean it's fluorite, but if I can scratch a penny with it, then I know that its hardness is more than 3.5. And that will help me identify. So there's fluorite. This one is called apatite. And this comes in at a 5 on the hardness scale. It is part of the enamel of your teeth. It helps keep your enamel hard and working the way that it should. Next one is called feldspar. It's spelled feldspar, S-P-A-R, but they don't usually pronounce the R at the end. You may have seen rocks like this. There are a lot of rocks that have feldspar in them, particularly like granite type rocks. It's usually kind of a pinkish color, not always, but it comes in at a 6 on the Mohs hardness scale, and that should be able to be scratched with like it should be able to scratch like a knife or a glass plate. They come in at a 5.5. I don't have a glass plate with me right now, but it is a 6 on the hardness scale. You may see that in landscaping and stuff. So if you're out on a walk anytime soon, you might look for some feldspar. Number 7 is our friend quartz. It's a pretty common mineral. The rose quartz and smoky quartz are sometimes used in like non-precious jewelries. You might see them in jewelry sometimes. Amethyst, which is purple, is actually a semi-precious gemstone. You may have seen that before. It's a form of quartz. It has a little bit of iron in it. And it rings in at a 7 on the Mohs hardness scale. So it should, because the steel nail that we have here is a 6.5, we should be able to scratch this nail with the quartz. Let's see if we can do that. I'm not getting a good angle on it. Hold up. Seeing my hand there. See if I can prop this up. Did it scratch the nail? Oh yeah, you see that there? Did it? Yep. Scratch the nail. It's a lot harder. Well, not a lot harder, but it's harder than the nail. So it'll scratch the nail, okay? Now, all the other ones that are lower than quartz lower than the nail, which is a 6.5, should be able to be scratched with the nail. Let's see if we can scratch our feldspar here. Let me... That's probably a little bit too close to it. Yeah, let's try this one. I don't know if you can see that scratch there. Right about there, that's where I scratched it. So this is a 6.5, the nail's a 6.5, the apatite is a 5, so the nail can scratch it. So if you're able to scratch something with the nail, then you know that it's less than a 6.5 on the Mohs hardness scale, and it may not be apatite, it may not be feldspar, it may not be fluorite, but you definitely know it's less than a 6.5, right? Our next one is beryl. Now in some kits, a number 8 is a topaz. Beryl is relatively strong. If I had a masonry drill bit, we might be able to scratch it with that. But beryl is the same mineral that emeralds come from. So if you've ever seen a green emerald, I don't know if there can be different colors of emeralds or not, but beryl is the mineral that emeralds come from. So relatively high on the hardness scale. Now we do have some little samples of what's called corundum and rubies. These are they're not polished or anything like that, but I don't know if you can see that very well, but that is a 9 on the hardness scale, and rubies and sapphires come from the mineral corundum. So if we had better quality ones, and if we would polish them up, it might be gemstone quality. It might be like a ruby or a sapphire. And we do have diamonds in this kit. They're not very good diamonds, but diamond is a 10 on the Mohs hardness scale. Can you see those little bitty diamonds in there? Look at that. Isn't that pretty, right? So we have 2 little diamonds in there, and these are a 10 on the Mohs hardness scale. The hardest mineral that we have on the scale there. And so this little diamond there, that little guy, to scratch everything else in our kit here. So we should be able to scratch even the corundum with it, and the beryl, even the ones that have a higher scratch to them. So that's the hardness, and we use the Mohs hardness scale and a scratch test to help us determine the hardness of a mineral. Now, I do want to show you a little bit of the streak test here. Let me show you, let's see if we can get sulfur to create a streak for us. Can you see that? Some minerals will leave a streak, some do not. They don't leave a very good streak there. Sulfur will leave kind of the yellow streak, kind of similar to its original color, but some minerals don't do that. Now, I think talc is going to leave a streak, and it will leave a whitish streak. But minerals like pyrite leave like a greenish black, I'll scoot that over a little bit, leave a greenish black streak to them. So a streak test is also something we can do to help us determine what mineral we have. And then I wanted to show you this mineral here. This little mineral is called mica, and it looks like plastic. This right here used to actually be one big rock, and it kind of peels off in sheets. There's another example of mica right there, a little bit darker color. And this is an example of a rock that has some mica in it. So it's kind of a cool little mineral. I really like mica. I think it's a pretty neat little thing. So we can use different properties to help us identify minerals. Once we know that we have a mineral, we can use things like hardness, luster, the way that it reflects light, crystal structure, like how its atoms are arranged, density, its mass per volume. We can start out with color, like sulfur is usually that bright yellow color. Its streak, like the color of its powder that's left behind. Its breakage, is it going to break off in nice even lines, or is it going to break off in jagged little pieces? And even unique properties like the odor of sulfur, or like the way that mica peels off in sheets, or if it fluoresces, or if it is magnetic. So those are some properties we can use to help us identify minerals. Make sure you know what a mineral actually is too. Remember that those minerals are naturally occurring inorganic solids with a crystal structure and definite chemical composition. If it doesn't have all those characteristics, it's not a mineral, it's something else. Thanks for paying attention. Sorry it's not that great of a quality, but I hope you learned something from today's little video. Thank you.